I thought I had my live now tweet ready to go, and it's not ready. That's a good way to go live and then talk about how you're not ready to push things on Twitter. It happens all the time. Oh, I did. It's on the. Oh, there it is. I'm on the wrong browser. That's what the problem was. All right. Oh, we are still live. Great. Thanks for joining us once again. I'm Sammy K. Powers, and this is the PHP Roundtable. This is a live podcast of developers discussing topics that PHP nerds care about. And the ultimate goal of this podcast is to learn a little something from each other. If you're listening live and you want to be a part of this little shindig, send a tweet to PHP Roundtable with a question or just a comment, and we'll try to get your question answered live if we can. We already have Nicholas Wittert chiming in, talking about the timing of the live episode. During the UEFA final, we were kind of figuring out what the UEFA final was. We were pretty sure it is sports related, but none of us are really into that, so we're all trying to figure it out. So we spend much of our time as developers figuring out the best way to read, mutate, and persist the state of our applications. There are many different approaches and philosophies attributed to managing application state, and event sourcing is one such approach. Today, we discuss what event sourcing is and how we can start integrating it into our PHP applications. Now that we know what we're talking about, let's meet the panel, and as always, in no particular order, we're going to meet the co-host of that podcast and co-founder of Money, spelled Monii. That's Beau Simensen. Welcome, Beau.
Hello, nice to be here.
Welcome back for another round.
Mm-hmm. Indeed.
I think most of you guys have actually been on here at least once, almost all of you. Next up is his famous intro he always likes to do, the incompetent hat, Ross Tuck. Welcome, Ross.
Thanks for having me back.
Absolutely. And we also have the organizer of there's like a lot of these acronyms that we throw out as developers all the time. This is one of my favorite ones, DDD. He's the organizer of DDD Europe and developing a DVD series on event sourcing called Event Sorcery. Sounds very cool. Welcome, Shawn McCool.
Hi, Sammy.
Hello, hello. And finally, we have Willem-Jan Zijderveld, and I'm really hoping I'm saying that right. He's the inventor of the event sourcing and CQRS library called Broadway. Welcome, Willem-Jan.
Hi, evening. Thanks for having me.
Absolutely. So let's jump right into this whole event sourcing thing. This is a really big topic, and there's many different approaches we could take, different angles that we could take talking about this. And me being someone who has very little knowledge of event sourcing, I'm going to be basically asking a bunch of questions of how I basically understand event sourcing at this kind of rudimentary level, and then we'll try to kind of come up with a clearer picture for everyone who might be listening in is also news to event sourcing. So from what I understand at the moment, event sourcing is basically like thinking of application state as or setting it up in a way that if we were to think of our application state as frames in a video, we could basically scrub through past states of the app and scrub up through, like as we scrub back, then we can scrub forward and kind of see the state of an application at any given point. Is that kind of a pretty good, like 3,000 feet view of event sourcing?
I'll just start, I guess. I think that the simplest way to explain it is that every time something happens that's relevant, you just record what it was, and then you tie to it any extra details that are necessary to really understand what happened. Then later you can take those events and turn them into state by running an operation one after another to see how they stack up. So it's just kind of recording what's happened and then generating state from those records.
I think the scrubbing thing that you're talking about is definitely something that you can do with event sourcing, but it's not necessarily what it's all about.
Cool. So what I guess when we look in for intros for event sourcing, typical examples start with looking from the perspective of maybe accounting and talking about how you might store a state of a bank account, or for example, like you don't just go in there and you change your bank account number, but you have a list of transactions and you either subtract money or you add money, and your state of your account is based on all of the sum total of those transactions added up. So that's basically closer to event sourcing, just transactions, and then you gain state only exists as a sum total of actions that have occurred.
Yeah, sounds a good summary.
Cool. Well, so how does this actually how does this play into like an actual app? So like if I just have like a basic CRUD app, is that a good candidate for event sourcing, or is there like very specific types of apps that are better for event sourcing?
When it comes to like really simple CRUD applications, the simple answer is no. Just no. Like event sourcing is really, really awesome. It's a great tool. But it really, really shines best in situations where you've got complex domain rules that are going on, like really, really sophisticated stuff. Even when it's something that doesn't necessarily sound complicated, for example, like a list of this has happened, and that happened, and that happened, that happened, that happened, those can take place in like really, really sensitive and important domains. Finance being like the most widely known example, but all sorts of other things like inventory, shipping, a lot of things, honestly, where there's like a delay of time, like the time is really a key factor there. And you're looking for something that has a certain degree of complexity or auditability requirements or complex decision making so that you can go back and find out what that was, or maybe something where data mining, like, you know, for trying to figure out what your customers might want to buy or what their shopping patterns are in the future, things like that, where the information is important because you're never getting rid of it, but also because it's just complicated or there's a lot of legal requirements. So would I write a simple CRUD application, for example, for like tracking who's borrowed what books from me or something? Would I, you know, it's just for my personal use, would I write that with event sourcing? Probably not. If I'm writing like, you know, who's borrowed books from a library scale international, you know, like countrywide system of libraries, maybe.
Cool. So if we were to look at like just maybe from the perspective of I build CRUD apps, I'm familiar with maybe the active record, and if I were to just think of like storing users into a users table and all this kind of stuff and trying to directly map what I might think of as an object to a table, I've heard that you don't actually store the current state in that way with event sourcing, but you store events that lead to that current state in the database. So I'm kind of curious, what does a database table even look like, or how does the database table structures look like with event sourcing?
I'll pick this up. Really can be really simple. It can be just a unique ID to determine which events belong to together, usually a UUID. Then it probably has some sort of value that will indicate in which order the events came in. And then you can have a field which has some serialized data in it that actually contains the events data. I think that's the most basic version that you will encounter. But usually there's a bit more information there. I mean, the date, time, when it actually happened, you probably want to know. Besides that, a lot of people also store what we call metadata. And there you can store something like a request ID, stuff like that. But in basic, most important information is often just some sort of serialized blob or binary data or whatever you want.
So the action is the first class citizen and the data is sort of like the secondary citizen in that database structure?
Yes. Yeah, correct.
Cool. And Ross, you were actually holding up a picture, a chart that people that are listening to the audio version can see very clearly. But what was that that you were holding up there?
Just basically what he was saying. I was joking that it's basically like it's an ID, it's often a version or a date number, and it's basically a serialized blob of JSON usually if you're talking about like in MySQL or Postgres or something. Like it's not necessarily even the action, it's not really the cause, it's the effect. So you might say something like, I don't want to get ahead and start talking about commands, for example, but it's like you say like, I want to borrow a book. So you say borrow a book, that's a command, and then you store the things that happen, like, hey, a book was loaned out, a book was, a person hit their limit on the number of books they can have, things like that. Those might be things that happen all at once or something like that, but you're storing the effects, not necessarily the original cause.
So you're still having a table called books, right, that you would store your book data in?
Not necessarily. I would have a table that's called events, and if I've got a whole lot of them and maybe I need to partition or shard them, I might have something that's called book events. And not to get too technical or anything.
So how is that? Go ahead, Shawn. It looks like you're about to say something.
So if you think about this bank transaction idea where you have deposits and withdrawals, let's imagine all you have is a collection of these events, and you want to come to the balance. How do you get to that? Well, you process them one at a time. For all of the deposits, you add to your balance, and that amount that was deposited is in the event as part of this payload. And then you subtract all the withdrawals, and then that's how you end up with that final state. The same process can be used for any types of events. So if a book was withdrawn or checked out, or a new book was added to the library, or any of these things, you can think about how you would handle that bank account balance and also apply that same kind of behavior to any set of events. So you go through them all, decide what does this mean. So it's a very use case oriented thing. You really end up with just the event stream holding all of the important information. But then for your system, you might say, I need to show every book that's checked out. Okay, for that case, then we make a maybe checked out books table in a simple example. And then we go through all of the events that are relevant to understanding which books are checked out, and then we update the state of that table. And so I think this might help answer your question, where's the books table? Well, it's more use case oriented than just having all of the books. We can create a new set of state for every use case we have. The books that are checked out, the books that we have in, overdue books, any of these use cases could use the same series of events to come up with a new set of state directly tied to that case.
That sounds pretty paradigm shifty when it kind of when I think of just a typical relational database that I would set up with, dealing with books and checking them out and things like that. So I mean, technically, you could even have an app that just has one table in it called events, and you got a UUID and maybe a date time stamp, and then just blobs of data, and then you can create everything you want from that. Basically, all the objects in your entire application.
Yeah, I mean.
Wow.
I mentioned how you can create the state in these checked out books table, for example, but you may not even necessarily need that if performance isn't an issue. You can just load up all of the books. All of the events, play them back into the series of objects and have that in memory. It's very paradigm shifty, yes.
Yeah, no kidding. And I was looking at some cool charts that really outlined how you could build an object from an event store, I guess, is what you would call it. But you have all of these events stored, and then you take them one at a time and you apply them to this empty object. You start with this null object, then you apply that the object was created and it has this name. Then you apply this other thing which gives it like a color, and then you apply this other event that changed its name, and you eventually just get to the state that it's currently in after applying all of those states. Do you do that every time you instantiate an object? Apply all the things of the events?
Depends a bit on what you want to do with the object, but especially when you're going to use that object to perform another action, then yes, you would definitely do that, because all the events would also guarantee that you are in the latest state, instead of that you try to get that separate table what Shawn was talking about that might be not up to date because you do that asynchronously or whatever. So then you would definitely get it from the events. Just for reading, yeah, you could use another table like Shawn said, but then you will go in another direction of things we want to discuss. But for simple use cases, yes, you could definitely just, if you want to get the details of a single object, get all the events and load it, because it's usually quite small, so it's not that big of a deal to get all the events and replay them.
Cool. So speaking of performance, what about the idea of having this object that's had millions of actions applied to it over the course of a really long time? How do you handle those use cases?
You can use something what people call snapshotting. So instead of when you load the object, you load all millions of events for that single object. you look for the latest snapshot, and the snapshot is just the state of an object after, say, a million events. That state that you save somewhere separate. And if you want to load that object again, you look for the latest snapshots and get all the events that came after the snapshot. So instead of loading a million, you load only 100 or whatever.
Cool. And would you say that snapshot in the same events table, just basically having a just like a state of that object at this point in time, and you just update it every once in a while, or do you have like a separate snapshot table, or how would you go about implementing a snapshot kind of cache, I guess?
I never really needed to go that far. So did somebody else got that far already in production?
Honestly, just chiming in real quick, the answer to me is like no, because like snapshotting is like it's sort of what we do all the time. We're really, really used to it, but in practice, like everybody worries that the events are super, super slow, but they're not. Like applying events is really, really fast, so it's kind of not a problem. It's like not a problem when you're doing it for a single object, like in rebuilding the state. It's like when you're doing it like across like several thousand, because, or like even when you're doing 20, 30, 50, 100 or something, because you're doing like a results page, you know. But even it's not really a big deal. So like everybody talks about snapshotting, but I've not met anybody in person who's actually had to do it. So.
Oh, when I said the million, sorry, Shawn, the million you need to load for a single object. I mean, that would take, if you do it in PHP, it would take, I don't know, 30 seconds maybe. If that is doable for your system because you do a lot of background processing, then who cares? And most of the time you use this, you won't be having a million events per object. Most people just don't do that.
And every object that has its own set of events kind of represents process. And all of those events that are firing, they have the idea of that kind of process, that thing that the event's directly tied to. So what you can do is when you're designing these objects and you're designing how these events are raised, you can actually just design it in a way that hopefully these things have their life cycle is such that they die and they kind of go away. And so over time, the events are raised and they are tied to this thing that happened, and then that thing goes away, and then another one comes up. And so they always have, hopefully, as few as possible events connected to them that have to be replayed.
Gotcha.
So as far as actual implementations, I think Proof has a snapshotting event store, and I believe their implementation, they don't actually store it in the event stream itself. They keep it on the side in another repository. So they have it set up such that a blob of the aggregate root gets stored in some storage facility somewhere. That comes out, applied to the object, and then they play the rest of the events since that snapshot had been taken onto the object. So I haven't actually used it in person, so we'll throw that out there. But as far as implementation, that's the only one that I've seen where it's actually been implemented in PHP.
Andrew Castell on Twitter actually just chimed in on that too. He says he's never had to use snapshotting, but definitely projections for read performance. Now, does that tie into the CQRS stuff?
Yes, definitely.
Awesome. Well, Beau, actually, believe it or not, I was listening to that podcast a while ago, and you guys were talking about CQRS, command query responsibility segregation, CQRS, and that was the first time I'd ever really heard about it. Is when I heard about it on your all's podcast. So, what is CQRS, and how does it relate to event sourcing?
Well, the general idea of CQRS is to have separate models for different purposes. So far tonight we've been talking about event sourcing as a primary way to persist your main business objects. And so a lot of the questions you've had is, well, isn't that slow? Isn't that complicated? Where are my books? Where's the books table? With event sourcing itself, there is not necessarily a books table. A lot of the things that some of us have chimed in to say, well, you could have a books table, you could replay all of the events into the books table as its own model. That starts to become the point where you have a read model. So that would be the read side as opposed to the command side. So all of the times that you need to make a change to, say, a book's status, whether it's checked in or not, you would write to the command side, and then anytime you want to display that information to a user or a system or an API or something like that, you would get that through the read side. So you'd have two distinct models, one for command and one for read. And when I say two models, there's not just one read model. You could potentially have dozens or hundreds of read models for the same set of data that would be on the right side.
Cool. So you'd have like a books read model and a books write model, and then those can be optimized, I guess, for reading, and then one could be optimized for writing, and that's sort of the another performance gain you can get out of that, or?
Yes, definitely. So you could have a completely different data store backing each model. In fact, you could have different data stores backing each read model. So you might have a search engine using Lucene or something like that for searching books by title really quickly, but if you want to have a succinct booked list, you might just store that in a MySQL or a SQLite or some sort of table like that.
Cool. So in CQRS, you also have commands and command handlers, and events and event handlers. Now this whole like thing. I feel like to truly understand. I have a cracky sound. Sorry to interrupt here. I'm going to edit this out in post production. Let me try to turn my mic off and turn it back on. Let's see if this works. Am I cracking? Still? Okay, guys, sorry, hold on just a second. This will not be in the audio version. Thanks for pointing that out, by the way. All right, so here we're going to the built-in microphone. That should be worse audio quality now. Wait, now that should be worse audio quality. Now I'm going to switch back. ATR? We better? All right. No. I am actually seeing the crackle on my recording on the Audacity. And I don't know why. Sorry about that, guys. I'm actually not really sure. I might actually have to switch to my other mic here.
Your built-in sounded pretty all right.
It did? Okay, I'll switch to that for now. Built-in microphone. I just have a lot of posts to do. All right, here we go. Post. Is this good?
Yeah.
Much better. Okay, great. All right, where were we? Command handlers. So we have commands and command handlers, events and event handlers with CQRS. What is there like a TLDR for that?
Beau's TLDR was quite good already. It's just quite tricky to grasp in a short time. Is there something specific or something you think, oh, maybe dive into that first?
Yeah, maybe just like a real-world example of how you might, how command handlers, events, and event handlers might interact with each other on just a for instance.
Yeah, we can. Very simple example. If we take the accounting, you can have a lot of events that say added some amount, credited some amount. Just a lot of events that happen to your bank account. And you have one, so that are commands that will happen in your system. As a side effect of that command, you have some event listeners that will create their own models of that. One model could be, for example, very simple, your balance as you see it. When you request your details, your balance. Another could be a model where you can search your transactions. So that's optimized for search. So you could store that in Elasticsearch, for example, or another search engine. And you maybe could even create another read model because your bank allows you to share some information to, I don't know, your accountancy firm or whatever. But that might be a very separate one because of security. Just thinking of stuff at the moment.
So, I think that, as a modeling perspective, that's pretty much how it goes. I think if you're looking for it in a really technical perspective, sort of just what the general plumbing is, what you might do is you create a small object that's a command. It says something like really boring example here, don't yell at me, but register user. I want to register a user. This is a little object. You fill it with the necessary data. It says email, desired password, full name. Okay? You put that into a little object, and you take that command, register user, and it's usually immutable. It's not really a thing that I get really religious about, but you take that little user object and you drop it into what we call a command bus. And a command bus is really just a fancy little function that maps your command object to a handler. Sort of like when you get an HTTP request, you map it to a controller action. That little command handler that looks up whatever object that is you actually want to change, and it passes the relevant data from the command onto the actual object. Okay, so you have a user model that maybe you're going to create or you're going to save or modify in some way, right? And then you save it. And the handler is responsible for loading that thing, calling the appropriate method on it, and saving it. And usually, like, that's pretty much it. You want to keep them nice and light. And then that actual user object, that's the one that's going to contain that data or raise the proper events. Now, when you save it, when the handler takes that model and you pass it back to the repository to save it, then it's going to unload those new events from it, and then it's going to persist them in the database, and then it's also going to spread them out to the listeners in the system. And those listeners are going to load those other things up, those other things like the checked out books table that you want to populate, or I want to pass this off over, or create a work order, or generate a PDF, or something like that. And those things are going to pick that up, those event listeners, and generate those things for you, and do whatever else needs to happen. And that's kind of the general plumbing mechanism, and it creates this sort of circular feedback loop where you shoot a command in, something happens that updates some kind of record, for example, the user receives that event, that extra information either directly or in the future, and then they take action based on it, and they shoot more commands in, and it doesn't even have to be a user, it can be a system, and it just keeps going and going and going and going. And that's kind of how it works, like on a plumbing level in your typical scenarios. There's a lot of other ways that you might implement this in practice, if you're doing microservices or using a message queue or all sorts of things that you can do differently. But that's like sort of your bog standard event-sourced application.
So another way of looking at commands is when you have this code in your domain that is going to, you're going to have these domain interactions which are going to end up raising these events. You're going to need to call some kind of method to trigger that happening. So a command is like that method call. It's like sending that message to that object and saying, do this. But then it's programmed at this more meta level. So now that we have like an actual class that represents that method call and actual fields that represent the arguments for that method. So we can then send that command in through the bus, and that allows us to do things like allow the command to be executed later, or do some meta-analysis on the command, understand when the commands are sent where, do the whole kind of decorator style thing so that you can wrap the command bus up with more and more decorators that will be able to process that command before it hits the bottom of the well, etc. So it's more like a design pattern way of re-implementing method calls so that we can do additional meta work on top of it.
Yeah, it's really just like it's a handy way of structuring it. In other languages, you could arguably achieve a lot of the same type of things you do with the command bus by having like AOP, but AOP is like kind of awful. And there's other things you could try in order to get it in different ways, but it's just a handy idiom that kind of goes well with this. It's not really, I think personally, it's not really directly related to event sourcing. And on a PHP specific note, I think a lot of confusion around commands comes with the fact that we represent these intents and these actions and stuff as classes, which can then have behavior. If we were in a language, for example, that had structs, I think like the implementation and the understanding would be like a lot clearer across the board, but maybe it's just me.
I think one of the other things about commands and events from a very high level is that commands are expressing an intent for something to happen. So you're asking to register a user. You don't necessarily know that that user is going to be registered as a result of that command being issued. Commands can fail. Commands can do all sorts of things, and generally there's only going to be one command handler. I think there are probably some exceptions to that, but usually there's going to be one thing in the system that responds to a command, and that will be one command handler. On the event side, once the events go out as a result of that command being executed, you could potentially have more than one listener to those events. So there's some very subtle differences between commands and command handlers and events and event handlers, but they're also very they're very different, but only subtly so.
Cool. That definitely helps to kind of everything that you guys were saying together helps to kind of get a bigger, like 3,000 feet view of event sourcing and actual implementation and things, and CQRS a little bit more. I'm curious if you guys have any common pitfalls that you see that people doing event sourcing or implementing CQRS for the first time fall into, the traps.
Besides wanting to event source everything in the application,
Yeah.
I think like the natural inclination is just to start modeling everything, right? But really, event sourcing has its costs, and it might be advisable to limit it to the areas in your system that it has the most benefit for you, of course, because software is expensive in general, and whatever you're spending time doing your authentication using event sourcing, you could be spending that time refactoring something or adding new features.
I think that the amount of plumbing that is required to implement full CQRS with event sourcing is not discussed quite a lot. I think people who do it realize it and understand, but I don't think that people's first impression of, wow, it sounds like you have to do a lot of stuff in order to do event sourcing and CQRS. It's not actually that far from the truth. There is definitely a lot of expense to having to build these things. It's really up to you to decide whether it's a business advantage to have the flexibility that CQRS offers when you decide if you're going to do it or not.
I think that there's another part of this too, and I think, like, first, a bit pet peeve for me is that people conflate a lot of these things into one concept, like this stuff that we're talking about with command handlers and read models and projections and things like that. Like, none of that is actually event sourcing. These are patterns that go well with the event sourcing to the point where they're like almost a de facto thing, but they're not event sourcing itself. And I think like that, there's a lot of confusion about that and a lot of cargo culting, honestly. Beyond that point, I also think that a lot of people, as others have said, underestimate the cost of this dramatically, partly because compared to ORMs, compared to active record libraries and things like that, event sourcing is so conceptually simple. It is so easy to write your own and do it, and you can just do it in a handful of lines of code, and it is awesome because it gives you this huge amount of object flexibility within your aggregates and your models, and it just feels so nice when you finally have that and you're not worrying about how do I map this with that, with Eloquent or Doctrine or anything like that. And that is really easy, but taking care of it afterwards can be a little bit trickier. And I think people underestimate.
I actually do want to dive in a little bit onto the actual business value that you kind of alluded to there. Like, what is, if I were to just back up and step out of the code for a minute and just kind of look at what this is actually giving, what value this is giving to the actual company organization that is behind the app, what are some of the biggest, maybe surprising things that event sourcing is going to give us maybe later down the road after we've used the app for a couple of years?
Probably the obvious one would be that a couple of years down the road you're going to have a new feature that you'll wish, wow, I wish we could have known what we needed, 2 years ago, and be able to implement this for all our existing users. And many times within an event-sourced application, you're able to do that if you've kept enough change along the way to be able to say, oh yeah, we're going to implement a timeline feature to show all of the changes against this aggregate. You may be able to do that just by turning it on. It's something that you didn't think you needed early on. You only discovered you needed it later, and now you have that information that's available to code that's been out for 2 years already. So I think that that's one of the things that you can do with event sourcing is future-proof your application in such a way that down the line you can potentially use the information that you're gathering now. So if you're gathering all of the information now the best you can, you're probably going to be able to use it later.
A fundamental consequence of sourcing your state from your events is that you don't lose any data. Everything that's been event sourced you have just going forward.
It's like a better version of soft deletes, right? If we've ever implemented a date deleted on our time as a timestamp on our fields or on our database tables. I thought it was just a complicated version of soft deletes, but apparently it's completely different.
It's a bit more than that, yeah.
It's fundamentally different, not just for the technical aspect of it. It's like you can see everything that happened and the intent, which is a really big deal. Not just this field changed, but why or what changed. But it also opens up to like a different type of modeling. And we talk about modeling like, oh, I'm going to model this as objects, or I'm going to model this as a database, or these are different types of modeling, and they're valid, and some are better at some things than others. But like the type of modeling that you can do with event sourcing is fundamentally different, and I don't think we fully understand it yet, but we're getting better at it, and I think that's kind of the most exciting thing.
Cool. Well, speaking of the database itself, I was actually doing some some research for the show notes and things like that, and I found this event store, which is called Event Store. It's an open source functional database, and so you can I guess you can store complex event processing. Or it does complex event processing, or I didn't quite understand. Is there like an actual database specifically for event sourcing that you would want to implement, or can you just use plain old MySQL? Or I mean, what about like Mongo? Like how would maybe a document database like Mongo play in with this? Do we have a lot of options with a variety of different sources for storing the persistence or persisting the state?
Has it? Oh, go ahead.
Yes, thanks. In theory, you can use a lot of storages that you can think of because of the nature of an event store. An event store, by nature, is append only. So you don't modify stuff, you just add new records over and over again. Which also makes that a lot of databases aren't necessarily optimized for that, but that's usually not that big of a deal because you don't do that much complicated logic on the event stream. But besides that, you also already named Event Store from Greg Young, and that's definitely an event store which is very much optimized for an event store for time-based data. So it has a lot of features that you probably want to use when you use event sourcing. Like, for example, it already has built in the possibility to create multiple models based on your events, which is quite nice. Sadly, I haven't actually been able to use it in a decent level, so if anybody has, please invite me as well. Awesome. But yeah, on the other hand, there are a lot of event stores you can build with really simple technologies.
I really like Greg Young's event store. But when I'm in my projects, I've only implemented my own solutions, basically. I guess his solution is maybe better for higher performance needs than I have. But one thing it does really well is it has the ability to do stream processing. So you can actually, in JavaScript, in the actual database system, actually store logic for if this event happens, store this state in this process. Then as these different events occur, you can update the state, and if we find that we're hitting some specific configuration of state, then we can start throwing new events. We can do things like replay a bunch of old events into a new stream, filtering out certain ones of those events that we don't want. And in general, you can do a lot of interesting time-based kind of querying with the stream processing in Event Store. So that's really what Event Store does best, I think. It stores a mutable collection of all of the events that have occurred, but it also has this built-in functionality to, in a very highly performant way, process the stream into new streams that you can then use to, like Willem said, as entirely new models.
Cool. So I would like to, we're starting to get to that point where we need to start wrapping this up a little bit, but I do want to quickly touch on what you guys would recommend as resources for specifically PHP when getting into CQRS and event sourcing. I love the faces that are going on right now.
I know a few, but actually naming them, that's the tricky part. I'll try to look them up really quick.
I think the get proof system is pretty nice. That community is super helpful. They're on Gitter, and they're similar to Broadway in that they're offering sort of a framework / library to help people get started with CQRS and event sourcing. So if you're interested in looking at that and want to get into the actual community and start talking with people, that's a good place to go. Candidate Labs has a IRC channel as well, and so if you want to take a look at Broadway, that's a good place to start also. And a little blatant self-promotion. Last week, Nomad PHP had an event sourcing and CQRS talk for PHP, which was from me. But that sort of gives a high-level introduction to a lot of the stuff that we've already talked about and kind of shows how the pieces go together as far as plumbing is concerned.
Yeah, I was going to recommend that probably Candidate Labs had some good information on that. I'm working on a series called Event Sorcery. That's the goal is to teach using PHP the full breadth of the ideas around event sourcing, CQRS, and as much DDD as we need to kind of provide some of the theory behind a lot of the ideas. So hopefully we want to build up from kind of an object design, object modeling standpoint, all the way to building something that's fully, very heavily event sourced. But there's also a lot of resources out there, like if you search CQRS and event sourcing, you come up with a lot of really good stuff.
Yeah, Microsoft has a really good documentation about that. You have CQRS.nu, which has some quite good information about CQRS itself. And then Axon Framework, which is a Java framework for event sourcing. They have some quite good documentation as well, but yet it's all Java examples, so maybe a bit less for the PHP community. But
Cool, awesome. Well, I think this has been a pretty good discussion on trying to get from somebody from zero to event sourcing, at least starting to dabble around within their own apps. I would like to start wrapping this up, and before I do, I wanted to at least mention the official GitHub repo for show notes. It's at github.com/phproundtable. There's a repo there for the show notes, all written in Markdown. I want to give a big shout out to Chris Shaw, who was rocking out the show notes for the past two episodes, number 48, Docker and PHP, and number 47, all about HTTP2. So thank you, Chris, for contributing those show notes. And if you are listening now and want to contribute show notes, just sit there, write some notes as you're listening and put them in Markdown and send a pull request. I'll give you a personal shout out and a link to your Twitter handle on the phproundtable.com website. So thanks again, Chris, for knocking out so many show notes over the past quite a few episodes. You've been doing a lot, so I appreciate that a lot. Last thing, wrapping up with the developer shout out, we always like to give a great shout out to somebody who's contributed something important to the community and has been selfless and a thankless job sometimes of just contributing to the community. So we want to recognize that awesomeness, and the way that we do that is send a thank you note, personal thank you note with a giant PHP Roundtable sticker and a $50 Amazon gift card sponsored by Laracasts. And Laracast is a great resource for learning new things about not only Laravel, the web framework, but also about testing and IDEs and command line-y things. There's lots and lots of stuff that you can learn, and Jeffrey Way is constantly putting new screencasts out all the time. I don't know how that man does it. He's just constantly cranking out the screencast, but it's a great resource for learning in a way that's just sitting back and eating some popcorn and watching and learning. So thanks, Laracast, for the continued sponsorship of the developer shout-out. And for this particular episode, the panel nominated Marine Hausenfeld. So, Mr. Shawn, why do we nominate Marine as the developer shout-out?
Yeah, so Marine, he has been working with event sourcing for quite a long time. He's been teaching and sharing his knowledge with others, and he recently started an incredibly successful meetup in the Netherlands where people can go, and it's a lot of work what he's doing and going through the trouble of sharing this knowledge and this experience that he's gotten from really, implementing event sourcing since way before I even knew it was a thing. So, thanks, Marine.
Absolutely. Thanks so much, Mariah. I will be reaching out to you to grab your snail mail address and get this gift card to you and send you the Amazon gift card. Um, so thanks for everything you've done, Mariah, and I want to wrap this thing up officially with some shameless plugs. Actually, who's got a shameless plug ready to go? I'm going to start with whoever's ready first. Anybody got some shamelessly promotionally things?
I feel like I've shamelessly promoted enough for the day.
Yeah, I think I did as well.
All right, so Beau and Shawn have officially shamelessly promoted already. What about you, Ross?
I am a freelance developer, and I'm officially available again from August 15th. So shoot me a mail at me@rossduck.com. Incompetent hat, great coder.
Awesome. Are there any particular projects that you kind of niche in, or that you really prefer, or you just kind of?
A little bit of this, a little bit of that. Just cut this part out during audio. It's fine.
All right, cool. Sounds good. All right. What about Willem-Jan? What about you?
Well, our event sourcing library/framework Broadway might be nice for people to look at, but yeah, there are plenty out there, so I wouldn't want to plug only one thing actually.
Awesome. Cool. Well, thanks again, everyone, for joining us in this discussion, and thanks for the panelists for taking the time out to help us all understand this stuff a little bit more. I mean, there's just so much information out there all the time. I just feel like as a web developer, we're just constantly in a state of trying to learn something new. So I hope that you'll join us in our next episode. We're going to be talking about what happened to PHP 6 and kind of reminisce about what happened there. If you've never heard of what happened, it'll be a good episode for that. And if you have something that you would like to share on the PHP Roundtable, I'd love to have you on the panel. Or if you just have a topic that you want to, that you'd like to see discussed, definitely go to phproundtable.com. There's a form there you can fill out, or you can just ping me on Twitter. I'm Sammy K, or ping PHP Roundtable. So I'd like to finally thank Mr. Beau, Ross, Shawn, and Willem-Jan for joining us in this discussion, and we'll see you guys in the next episode. Peace.